on, I believe the whole first part is no calculator. So here we go. Practice test 2, chapter 3. Consider this function. Is it growth or decay? Decay. How do we know? Well, the number in the parentheses is less than 1. The number in the parentheses is less than 1. What is the percent decay then? So it's a decay problem. What's the percent decay?
39%.
39%. How much less than 1 is 0.61? Well, it's 0.39 less, so that's 39%. What is the initial value? 0.82. That A, exponentials are A times B to the x. That A number is the initial value every time. Speaking of exponentials, now you're going to write one. A times B to the x. You got to remember, that's the format. We'll write the equation of the exponential. All right, tell me what you know about this.
A equals 1/2.
A equals 1/2. Now, if you remember that, that's always true. You can always do that. That will always be the case. If you can't remember that, then you're going to plug in this for y and 0 for x. That's going to go to 1, basically disappear, and you have A equals 1/2. So y equals 1/2 e to the x. That was a quiz question on one of our quizzes, and if you did that much, you got half credit, because you got half the answer there. Now, how do we get the other half?
Plug in the other point.
Plug in the other point, so 81/2 equals 1/2 e to the 4th. Now, we do not need to fear this, people. I know there are fractions in there, but if we times both sides by 2, can we get rid of those fractions? Yeah. So 81 equals b to the 4th. So then we will 4 through both sides.
And that's 3.
And what's the 4th root of 81? 3. Scott, where's your packet?
I can't find it for some reason.
So those are supposed to be for the kids who have been absent, so now I'll probably run out. The 4th root of 81 is 3. So b equals 3. Now, I'll write my answer. My answer is y equals,
1/2
what was A? 1/2
times 3.
times 3 to the x. And that's how I write it. That's the equation. Now we have a bunch of exponent equation or exponent expressions to figure out. Remember, this is no calculator, so we're going to have to maybe do a little arithmetic, maybe not. All right, here we go. First one. What's the very first thought you have when you look at that problem right there?
1 over.
It's 1 over. So 1 over 81 to the 3/4. That's your first thought. We do not like negative exponents. We need to get rid of them. All right? What's your second thought?
4th root 1 over.
Radical, because fractional exponents are radicals, right? And what radical would this be?
4th root.
The 4th root
Cubed.
cubed? Well, what's the 4th root of 81? We actually just did that. The 4th root of 81 is 3, but this time I have to cube it, so the answer is
27.
1 over 27. Go one step at a time. Don't be overwhelmed by the whole problem. Do what you know how to do. 1 over radical, and then just figure it out. What about this guy? Oh, here,
over.
this one.
1 over.
That's gonna be 1 over. Well, a 2 cubed is 8, so that's 1 over 8. Now, guys, I know you know this, but take your time and think about it. I can't tell you how many times I'll get a 6 down here. This is not 2 times 3. This is 2 times 2 times 2. All right, what happens here?
Flip it.
The whole thing flips. You can't really 1 over this one since it's already a fraction. You don't really want to 1 over it, so we'll just flip the whole thing. And then we square the whole thing. So 9 squared is 81. I do expect you to know that. 16 squared, you may not know it, so you might have to figure it out.
1,250.
And it's 256. I'll try to keep the numbers a little smaller,
Quite a lot.
right? And that's your answer. That's your answer. If you miss this next one, you need to be embarrassed. Because what happens when an ln and an e touch each other?
So it just equals those.
They go away, and so what's the answer? -6. When an ln and an e touch each other, whether it usually happens to us in our word problems, our PERT problems, but it can happen anywhere. When an ln and an e touch each other, they're gone. So all I have left is -6. That's the answer. What about this one? I'm gonna go ahead and set it equal to x. You don't have to do that, we'll talk about the other way to do it, but if I set it equal to x, then I know that I have to loop-de-loop, because when a logarithm equals a number, it's a loop-de-loop problem. So 5 to the x equals 25, so x equals 2. Now, some of you may have wanted to rewrite your problem as 5 squared. Isn't 25 5 squared? So if you wrote log base 5 of 5 squared, those cancel out because the 5's match, and the answer is 2. It doesn't matter how you do it, you can do either one of those ways, whichever way makes sense to you, but the answer's 2. Okay? All right, let's look at this next one. It's a big mess. And if you look at the whole thing, you might be overwhelmed because there's so much going on in that problem, and it's got negatives and I don't know, a whole bunch of stuff. But you don't need to be overwhelmed because you can clean it up pretty easily. Let's look inside the parentheses first. You don't have to, but I think it makes it easier if you look inside the parentheses first. Really can't do much with the 3 and the 4. What about these guys? What's gonna happen here? Isn't the 4 going to the top and the 3 coming to the bottom? Isn't that what's gonna happen? And then you guys, I'm gonna go ahead and take it one step further. What happens when you have 4 x's over 3 x's?
1 x on top.
1 x on the top. So first we'll swap them, and then we'll recognize that, oh gosh, they're both x's, so I can cancel some out. 4 on the top, 3 on the bottom, there'll be 1 extra on the top. What about the y's? Oh, we have the same thing, don't we? 1 extra y on the top. And we still have to square it because of the original 2. So now we square everything, so what have we got? 9 x squared y squared over 16. So it seemed scary one step at a time, not bad at all. Speaking of not bad at all, look at the next one.
12.
It's 12. Don't miss this one, guys. Oh, please do not miss that one. That one is 12. Now this one, it's just like that, this guy right here. It's exactly the same kind of problem as this one. So if you want to, you can set it equal to X, and then it looks like a loop-de-loop problem. Except there's no base, and that's what I have to start with.
Log base
10.
number.
What is the base?
Log base
10.
number.
10. There's a 10 there. LOG means 10. If there's no other number, it doesn't say log base 7 or log base 5, then it's log base 10. So 10 to the X equals 110,
-1.
and X has to be -1 because we all know 1 over means a negative exponent. This is 1 over, so that exponent has to be negative. Since it's still a 10, it's just 10 to the first, or negative first. Now, you could also have done the same problem by rewriting 1/10 as 10 to the negative first. That all cancels, and the answer is -1. You can do it either way. All right, what about I? 3/4 to the -2nd. We're gonna flip it and square it. So that's gonna be 4/3 squared, which is
16
16 ninths. Boy, we hope there's a whole bunch on the test like that, right? Oh, wait a minute. Larry, do you know what problems are on the test? Yeah, they're all these, right? So there'll be one like that on the test. How about this guy? 6. When an E and an LN touch each other, guys, they're gone. So the answer is 6. Page 1, done. All right, we didn't need a calculator for any of that, and we're still not using a calculator. Now we're going to solve some equations. Okay? So let's look at the first 4. When you sit down to take a test, you always are told to do the problems you know how to do first, right? So let's look at the first 4. Does anybody know how to do any of these? That's the first, just the first 4. Anybody know how to do any of them? Jacob?
The first one.
All right, what do you do with the first one?
Loop to loop.
You loop-de-loo it. So the first one is going to be a loop-de-loo. I keep telling you, I hope you're listening, that whenever you have log equals number, you loop-de-loo. Whenever you have log equals number, you loop-de-loo. So 4 to the 3rd equals x plus 1. 4 to the 3rd means 4 times 4 times 4. You might have that memorized because we use it a lot, but if you don't, you can figure it out. 64. So it looks like the answer is 63. Subtract 1. All right, does anybody see another one? Eddie?
On the second,
And what are you doing with the second one, Eddie?
divide by 4.
All right, Eddie says I'm gonna divide by 4. Kids, we always get rid of that extra number. So he has 3 to the x equals 9. Oh boy. What's x? 3 squared is 9. First step. divide by 3. It's just like this one. We gotta get rid of that extra number, so we're gonna divide by 3. So log x equals 2. Is this log equals a number? Yep, and what do we do when it's log equals a number? Loop-de-loop, but I don't have a base.
Log base times.
It's 10. So 10 squared equals x, and x equals 100. This one looks hard. What's the first thing that has to happen? We gotta divide by 27, so 243 divided by 27. Looks like that might be 9. It is, it's 9. So 1/3 to the 2x equals 9. I divided both sides by 27. What do you know about 9? It's 3 squared. So I can write 9 as 3 squared. Can I write 1/3 as 3 to a power? Negative what? Negative 1. Isn't 1/3 3 to the negative first? Okay, now pay attention. What am I trying to do? What was the point of this? I needed to make these two numbers the same. So when I saw 9, I immediately thought 3 squared. So then I knew I had to make this into a 3. Well, it's a 1/3, so that's an easy switch. Give it a negative exponent, and then it becomes 1/3, right? As soon as the two purple things match, the exponents are equal. So negative 2x equals 2. It looks like x equals negative 1. That one was a little more complicated than any of the other ones, but still not too bad. Anybody have a question about the first 4? All right, let's look at the next 4. Again, let's see, are there any that jump out at you like, oh, I know how to do that, I know what to do?
The first one.
The first one? All right, hang on, let me catch up here. All right, what are you gonna do with the first one?
Combine the logs.
Combine the logs. Guys, we have to always combine the logs. We have to combine the logs. You cannot have 2. So when you combine them, it's going to be log base 4 something equals 1. What's going to be in the something?
3x plus 3.
You're going to multiply these, aren't you? Because of the plus. So 3x plus 3, it's like a distributive. Now what have I got here? Say again, what have I got here? I've got a logarithm equal to a number. What do I do when I have a logarithm equal to a number? You loop-de-loo, right? So 4 to the first equals 3x plus 3. So subtract 3. I got 1/3. Has anybody already done this? Did you get 1/3?
Yeah.
Perfect. All right, what about the other 3 here? We have 3 more to go. Any of those look like something you could do?
Divide by log
Which one?
for f.
Ah!
Or no.
She said,
You add them together.
I'm going to cancel out these log 4s.
No, don't do that.
Can't do it. what do we have to do first?
Combine.
Combine. So, when I combine, won't it be another multiply?
Yeah.
So we're gonna multiply these two. So I get 18x plus 9. Now, this is not a loop-de-loop, because it's log equals log. So now I can get rid of them and do this. Subtract the 9 over and divide by 18. So it looks like negative 1/3 is my answer. Everybody moving along with me here? Why do some of you have coats on? Notice Xavier does not. Okay, how about this one? Do you have any thoughts on this one? Loop-de-loop. Guys, ln is log base e. So don't we have a logarithm equal to a number? And any time we have a logarithm equal to a number, we loop-de-loop. So e cubed equals 2x, and x equals e cubed divided by 2. And that's it. We don't have a calculator, so that's just it. That's our answer. Finally, what about this guy? Oh no, we can't divide by 4. That's the base of an exponent. If there were a number out here at the front, I would divide by that. But you can't divide by the 4. That's not a multiply. That's an
Add a log
exponent.
to this x in front.
Now, Scout says I could take the logarithm of both sides, and that would work out fine, except I don't have a calculator. So if I logged both sides, Scout, I would have x log 4 equal log 32, and my answer would be log 32 over log 4, which without a calculator, I can't do. So, this is a no calculator problem, and I'm kind of surprised that you haven't picked up on this. 4 and 32 are not random numbers. It's not like 4 and 31. What is special about 4? 4 is 2 squared. What is special about 32? It has to be 2 to something. It has to be. So what is it? Well, if you don't already know, just start doing it. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so it took 5 of them. If I can't use a calculator, this has to happen. You'll always be able to match them up, 2 and 2, 3 and 3, whatever, if you don't have a calculator. That's the only way to do it. So 2x equals 5, and x equals 5 halves. All right. Okay, how about the next one, guys? You know what you're supposed to do here? You're supposed to combine it. So we're supposed to have one logarithm.
Log 2x plus 3y.
So when I put them together, that's a plus. So when they go together, won't they be a multiply? Now, what is it, what happens to that two?
Exponent.
That's the exponent on x. And the 3 is the exponent on y. Remember, a number out in front of a logarithm is an exponent. So this is an x squared, and this is a y cubed, and they're gonna get multiplied because their logarithms are added. Now, this is the exact same thing backwards. I'm pulling it apart. So I'm gonna have a log of x, a log of y, and a log of z. You're gonna have a logarithm for each letter, just like up here. Now, there's no exponents in this problem, so I don't need to worry about any numbers out in front. All I need to do is figure out if I'm adding or subtracting.
Log x plus log y.
These two are getting added because x and y are multiplied. This one's being subtracted because the z is being divided. Everybody see that? We have 3 things going on, 3 letters. Okay, now I need a calculator for all the rest of the test. So here we go. Log base 5 of 10 equals x. 3 times 2 to the x equals 15. All right, we'll start with those two. Here we go. Who's got an idea?
Loop-de-loop.
This problem is a loop-de-loop. Let me say it again. I keep saying the same thing over and over again, but you gotta figure it out. Whenever you have log equals a number, you loop-de-loop. Now, when I loop-de-loop this one, it doesn't really give me my answer, does it? Notice where the x is. What happens when the x is the exponent? Think about our word problems. Every time we did like a PERT, and the x was the exponent, what did we
You
end
need
up
a
having to do?
logarithm.
Logarithms. We need the logarithm, so I'm gonna take the logarithm of both sides. This exponent then, this exponent comes out in front. So now my problem says x log 5 equals log 10. I want to know what x is, so what will I have to do to get x by itself? Divide. So log 10 over log 5. So I can type that in.
X equals 1.43.
Let's see, log 10 divided by log 5. Did you say 1.4307? Look at it carefully. We're gonna divide by 3 first. So, Plumber, do you see now the difference, the way this looks different? So I'm gonna divide by 3 first. So 2 to the x equals 5. Now, if this number had been a 4, I could do that problem without a calculator, but it's a 5. I need to know the exponent. What do I have to do to get that exponent?
Same thing as last.
Same thing as last time. Take the logarithm of both sides, pull the power off, and divide. So Jacob said, do the same thing as last time. Yeah, we keep doing the same thing over and over again. When you need an exponent, you need to take the logarithm. Did you get 2.3219?
Yes.
Divide by 5. We have so many common themes here. We always get rid of that extra number, right? So we're going to divide by 5. So e to the 0.13x equals 12/5, which you can leave as 12/5 or write as 2.4. It doesn't matter, since you don't have to round it off. If it were 12/7, we would leave it as 12/7. Now, I need to figure out my exponent.
ln.
I'm gonna take the logarithm of both sides, but since there's an e in it, I'll do the natural logarithm of both sides. That will cancel. That's what makes it so cool. 0.13x equals ln 12/5. So x equals ln 12/5 divided by 0.13. $6.7344. Anybody have a question about a step there? Well, the only thing left are our word problems. So remember, we have two formulas. We have PERT and the other one. So let's read question number 8A. The first thing you have got to do is figure out which formula you're going to use. So is it PERT or is it the other one? It's the other one. And the clue is, it says in the problem, compounded monthly. Compounded monthly is that formula. As I read the problem, I notice that there's really only one number in the whole thing, and that's 11 years. So I think my T is going to be 11. But what about the rest? I gotta have other numbers. What's going on here? Okay, it's doubling, so I can start with whatever I want. So Eli, what do you want to start with? 100? If Eli starts with $100, then he is gonna end up with $200. If I start with $4, I'm gonna end up with 8. It doesn't matter. Do I know the interest rate? That's what I'm trying to find, right? Do I have an N? 12, because it's compounded monthly. Now I like to, you've heard me say this before, I like to figure out that exponent, just make it a single number, so it's 132. What's the first step to the problem. Divide by 100. You always do that first. You always get rid of this. So 2 equals 1 plus r over 12 to the 132nd. This is a terrifying looking problem, but we've done it before. We've done one exactly like it. Do we need logarithms? No. You only use logarithms when x is up here, and it's not. But to get r by itself, I do need to get rid of this I need to get rid of this. So who remembers what we do?
132.
We take the 132nd root of both sides, because that will cancel that out and leave me with this. Who remembers, because we went through it, who remembers how to get the 132nd root on our calculator?
You hit
You
132
gotta
math.
type in the 132 first, and then math,
Option 5.
option 5,
1.0.
2,
Whoa.
1.0053.
1.005,
Times 12.
okay, not yet. Not yet, Scout. If you're gonna solve this equation, you're not gonna times by 12 first, you're going to subtract 1 first. And then you will times by 12. So I'm gonna subtract 1 times by 12. I got an interest rate of 6.32%. Notice, your calculator said 0.063179. Rounding off to 4 would make this a 2, and it's a percent, so you gotta move it over. Wow, that problem was, whew, big. Alright, you got it figured out? Alright, B, word problem B, step 1, figure out if it's pert or the other one.
Other one.
It's the other one. So, that one, I'm just gonna leave that one up there, it's the same formula, okay? So here we go. Got lots of numbers in this one. How much will be in the account at the end of 12 years if $10,000 is invested? Okay, what's the 10,000? That's the start. What's my interest rate? Be careful. 0.02175. What's my N? 4, because it's compounded quarterly, and T is 12. So my exponent is actually 48. Do I need logarithms? Do I need any special buttons? I just type it in. That's what I got, $12,973.10. Jacob, you got that? Other Jacob got it too? Good deal. Those are the best kind? All right, last one on this practice test. the question, figure out the formula.
Hurt.
This is gonna be a PERT. How do we know this one is a PERT?
It's not money.
Not money. That's your big clue. Kishad. Sit up. Are you sick? Okay, then just stay awake, please. All right, so here we go. What do I know? What's A?
987.
987. What's P?
432.
432. P is just E, don't plug anything in. What's R?
I don't know.
I don't know. Oh, that's bad news. And T is 15? And I shouldn't have said that, but why, what am I thinking? When I see that R up there, I know that eventually I'm going to need logarithms. This is not gonna be a type it in problem. I'm gonna have to do some work. What do I do first?
Divide 432.
So I have 987 over 432.
Ellen, both sides.
You said that I was gonna need logarithms because my variable is the exponent. Since the problem has an E, I will ln. That will cancel these out and leave me with 15R.
Divide by 15.
And to get my answer, I will just divide by 15. So ln 987 divided by 432
$5.5.
divided by 15. 0.0551.
So 5.
Yeah, I think it doesn't ask for the percent, it just says the growth constant. So if it had been an interest rate, if it was a money problem, Eli, and it said find the interest rate, then you would say 5.51%. But the growth constant is just what it is. All right? So we just took the whole test. All right? So what we're gonna do now, I'm not gonna blab on for the whole time, but I want everybody to take a second, look through practice test 2, we've done them all, we just did them. Find a problem that you struggled with a little bit, maybe are still struggling with, and we'll do one extra practice, and we'll do that for 2 of you. So go ahead and see what problem on the whole test there that you struggle with. And we will do one just like it to help you unstruggle. Yes, Mr. Bettner.
May we do one of the ones where you like solve?
Can you give me the problem number
Yeah,
there?
it's H.
On
4H.
4H? Yep.
4H.
So a problem like 4H would look like this. Okay, so this is a no calculator problem. It's not on there. I made this one up, but it matches 4H. It's a problem done like 4H. What do we have to do first? You have to divide by 5. If you have an extra number, you have to get rid of it. So 3 to the 2x minus 1 equals 9. And 9 is 3 squared. So 3 to the 2x minus 1 equals 3 squared. So 2x minus 1 equals 2, and x equals 3 halves. Now, what about something like this, along the same lines? But what about something like this? 4 times 9 to the 2x plus 1 equals 108. Divide by 4, so 9 to the 2x plus 1 equals
27.
27. Now, when you see the number 9, this should pop into your head, right? So I'm gonna think of that 9 as 3 squared. Now, if I do that, then I have to think of this 27 as 3 to the something. Is 27 3 to the something? It's 3 to the third, because it's 3 times 3 times 3. Okay? So this is a distribute, so 4x plus 2 equals 3, 4x equals 1, x equals 1/4. All right, there's a couple of them, Graham. All right, one more of you, one more. Who else found something that we need to do? Scout, give me a problem.
4, where it's,
For
F.
4f. All right, so another problem like 4f. We're just really doozy it up here. Yeah, this is a doozy, but we got it. We got it. We got it. Full logarithms. The biggest goofball in the class is going to cross all those logarithms off. There's going to be a big red X on your paper because you can't do that. What do we have to do before we do anything else? We gotta combine them. So these are gonna go together as log 4 something. And these are gonna go together as log 4 something, right? How will these two go together? That's gonna be a multiply. So 6x minus 3. How are these two gonna go together? A divide. So that's x plus 1 over 2. Now what? Log equals log. So now we can drop those off and solve 6x minus 3 equals x plus 1 over 2. So what do we do first here? Multiply. Subtract the x. Add the 6. So x equals 7/11. Okay, Scout? So we put together with the times over here, because of the plus. We put together with a divide over here, because of the minus, and then we could drop them. As soon as it says log equals log, you can drop them. Okay? All right.